Okay, so now let's look at problem 98. This is validate binary 3. Oh, nice. Validate binary search 3. Given the root of a binary tree, determine if it is a valid binary search tree. A valid BST is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key. So we are given the condition 1, left subtree contains only node with key less than node key. Okay, so we know that the left subtree of L is less than the root of L. The right subtree contains only node with keys greater than the node's key. As for the right subtree, the values are all greater than the node's key. 3. Both left and right subtree must also be binary search tree. So left subtree and right subtree is a BST. Okay, so they are recursively satisfying the condition 1 and condition 2 as we move along any node. Alright, I think I understand the problem now. Now let's look at the examples we are given. Examples that we are given. We have examples 1, at the root we have 3, left is 1, right is 2. We can see that this is a binary search tree. Correct. Second example, we have 5, the left is 1, right is 4, 4, left is 3, right is 6. So is everything, okay, so I see that there is a problem there because 3 is less than 5, but it is on the right subtree of the root. Yep, and the 4 also did not satisfy the condition. Okay, I think the problem is clear to me now. Let's come up with some possible approaches for this problem. On top of the top of my head, I can think of one way. So I think we could think of one way and could think of a possible way by recursively search to traverse the tree and look for Actually, we missed a step here, so I would like to ask a few clarifying questions. First one is the number of nodes. Then we are given the number of nodes is between 1 and 10 to the power of 4. Then that is not much to clarify. Now let's continue with our exploration on the possible solutions. So as mentioned earlier, I would like to traverse the tree recursively. And by doing so, I'm gonna record what is the maximum possible value and the minimum possible value that could be allowed in the current node. So meaning that when I start at a node and I move down to the right side, okay, let me write it down. When I move to the left, I'm gonna set the max is the value of the current node. However, if I move it to the right side, I'm gonna set the minimum value to be the value, the current node value. Meaning that as I traverse the tree, I'm gonna set the left and right boundary of the node on that subtree. Does this sound reasonable to you? Yeah, so let me try to do that on our current example. So we have 2, 1, 3. And then as we in the first example, we have 2, 1, 3. And then as we move to the left, it all has to be less than 2. While on the right side, it all has to be more than 2. And it satisfies the condition. So 2 also satisfies the condition, that's why it is true. Now the second example, we have 5, 1, 4. Left side has to be less than 5, right side has to be more than 5, which did not satisfy. Okay, I think I'm pretty good about this. Where to start implementing unless there is a further optimization that you would like me to explore. I'm assuming there is no, and now I'm gonna start working on the implementation. So here we are given is spelled BST. I'm gonna create a new function to accommodate my needs, where I would need the root, the left boundary, and the right boundary. So the left will represent the minimum value that I need to get, and the right would be the maximum value. So let's see what we need over here. I think in Python we could set like negative infinity and positive infinity. So I think that could be helpful in our case here. So now let's do the check function. So what do we need here? So in check, we would need to see. So if root is outside the left and right boundary, then it is not a subtree. Yeah, it is not a binary search tree, then we just return directly without the need to check all the children. I mean the subtree of itself. That's that. I mean the subtree of the left and right child. So here we are gonna check if root is less than L or it is more than the right. Then we return false. Otherwise, we return the then we check the left and right. So here, the left, if we go to left, then let's see, can we just directly set it? If we go to left, then we set the maximum value. Okay, so I think we can just take the current one, because every time we move to the left, all the value has to be smaller. So on the left subtree, whenever we move to the left, we must have set a lower value than the current allowed one, a lower maximum value than the current one. Okay, so we don't need to check whether the file, whether we have to whether the current file is less than the current right boundary. Then hit and check. Okay. Alright, so let me quickly go to the code again to make sure I don't miss anything. So first, we create a function called check, and then we check whether the root is less than the minimum boundary or it is larger than maximum boundary, then we return false. Otherwise, what we need to do is we need to check whether the children are satisfy the two conditions. Okay, so I think this could work. Now let me test the code with our examples given. Okay, so we forgot one thing. So there is possibility that the current node is null, so we also need to check if not root, then we just return true. Alright, I think this would work then. So for the first examples, we have 2, and then we in the there is no left boundary at this point, and there is no right boundary, so it can be anything from negative infinity to infinity, which is true. And then as we move on to the left subtree, we check we set the okay, we forgot to set the left and right and right. So if we move on to the left, we set the maximum value to 2, and if we move on to the right side, we set the minimum value to be 2. And then as we can see, the child also satisfies the condition. At this point there is no more child, so we return true, and then basically towards the top we return true. In second example, we have 5, 1, 4, and as we can see, the left is true. The right, however, we see that 4 is not more than 5. Okay, so at this point we return false. Okay, so maybe it's time to try out our solution in LeetCode. So here I'm gonna create a function called check self root left and right. If not root, return true. If root is less than or equals to left, or it is more than the right, don't forget we are checking the value, and we return false, else we return self dot check root dot left. As we move on to the left, remember that we are updating the right value to root dot now and self dot check root dot right. Set the left to the file and then the right. Okay, now here we just return the self.check starting at the root, meaning is minus infinity, the right is infinity. Okay, let's try to run it. I think the infinity is not set that way. Okay, let's follow. Okay, so what's wrong here? Oh, okay, so the positional argument. So let's just remove that. Yep, we got it correct. Now let's try to submit it. Hopefully we got this right. And yes, we got this right. Somehow there are much more efficient solutions. So let's look into that. It's valid. So this is more or less what I am doing. How about the other? Let's look at another solution. Yep, still the same one. Okay, I think people are mostly doing about the same thing. So let's just take it as it is. Thank you, everyone.